Hey everybody, this is our lesson on nutrition and energy flow. So energy in any ecosystem, we start with our autotrophs, which make their own food um, because they don't have to rely on anything else to eat. So these are known as our producers. And then we go to our heterotrophs, and we know that heterotrophs have to feed on other organisms. So the different types that we have here are herbivores, which will eat the autotrophs, right? Because our autotrophs are plants. Carnivores, which eat other heterotrophs, omnivores, which eat both, scavengers, which eat the dead carcasses, and then decomposers, which break down dead organisms that are left over. So all heterotrophs are called consumers. Then we label them based on their level of consumption. And I don't really know what. Yeah, so all matter that we look at goes into the energy cycle of an ecosystem. Come on, there we go. And we look at this energy in terms of trophic levels. So trophic levels are feeding steps, and the first trophic level are the autotrophs. So that's our biggest grouping, okay? Second level is the first order consumers or the herbivores. Third level are the carnivores and omnivores. Fourth level is the are more in-depth carnivores and omnivores. So as we look here, this is just a basic setup. So as you can tell, it kind of shapes like a pyramid. We get the top of the food chain, if you ever heard that, it's going to be those third order heterotrophs up top. To show matter and energy moving through an ecosystem, scientists will use food chains, which we have here. And it's a simple model where you literally draw what you start with, arrow, what would eat that, arrow, what would eat the previous thing, arrow, and you keep going from there. So algae would be our autotroph that we start with. Well, fish feed off of that, so they're the next step. And then herons feed on the fish, which is the next step. And then whatever would eat a heron would be the next step. So food webs show all the possible feeding relationships in an ecosystem, and they are not as neat as our chain that you just saw. So webs are messy. So grass, which is our autotroph, can feed crickets, or it can feed mice. Okay. Well, then the mice can feed birds. The bird can eat the snake. I'm sorry. A snake can eat the bird, or a snake can eat the crickets. Whereas a hawk can eat both the small birds, the snakes, and the mice. So that just gives you an idea kind of how it looks. This is a much neater version of a food web. But it shows you, these two up top, these would be our third order herbivores. We've got our autotroph, our producer. We've got our first order, second order, third order. And then we can also look at these in terms of an ecological pyramid, which is the food pyramid for an ecosystem. So it's our trophic levels. Remember, our plants and stuff go at the bottom. Our third trophic level goes up top. But keep in mind, we have more energy in the autotrophs because they make their own. As things are eaten, we're consuming things for energy, but you're losing energy at each step. Between each step of the food chain, food web, or pyramid, energy will be lost through heat, which is that's a natural thing. And only about 10% of the energy in each level will be transferred to the next level up. So if you're at 100% of energy here at the bottom, you only get 10% of that. Well, then 10% of 10% is 1%. Then 10% of 1% is 0.1%. So as you can tell, the energy goes down a lot the higher you move up this list. And then biomass is the total weight of living matter in each trophic level. So you would obviously, least weight to most weight up top, usually, depending on what's in your food web. So let's talk again about autotrophs really quick. So remember, these are our producers because they make their own food. So we're looking at plants here, plants, algae, things like that. Heterotrophs, so mini feeders, these are our consumers. Anything that eats autotrophs would be a heterotroph. That also, though, includes your omnivores, your carnivores, all that good stuff as well. And then we've got decomposers, which we know break down material, and those are your fungi and your bacteria. Herbivores, it's got herb in it. We know herbs are plants, so that's plant eater. And they eat just the autotrophs. They do not eat other forms of meat, okay? So these would be cows, rabbits, things like that. You've got carnivores, which are the meat eaters, so they eat other heterotrophs, but not autotrophs. And these would be like lions. We've got omnivores, which are more like what we are, should be at least, that eats a variety of plants and animals. Scavengers, which we know eat things that are already dead, so that would be like vultures. And then we can look at those types, carnivores, herbivores, things like that, and use those to make our food chain. So this, again, models how energy moves through an ecosystem. So if we're starting with grass as our autotroph, our producer, we would go to crickets, which would be our primary consumer, so our herbivore, right? Then we would go to our secondary consumer, which would be the bird. And so let's look at this example here. And then we've got just a couple questions here. I went through that last one really quick, so I wanted to kind of show you this example here. So who has the most energy available in the system? Would it be the producers, the primary consumers, the secondary consumers, or the tertiary consumers, the third level? Who eats the mouse? Okay, so remember, we don't go the lines to the mouse, we go the lines away from the mouse. And then what would happen to the number of coyotes if the number of deer decreased? Okay, would they be okay? Do they have other things to eat? Or would they die out if the number of deer die out, right? You have to look at if they have more than one possible food source. And then you are going to, in your notes, write one food chain from this web. All right, guys, so this is the end of our notes, and hopefully you learned a lot about the energy in an ecosystem.